Hey guys, hello everyone. So we're gonna learn how AI agent work. So on this flow, we'll try to understand. I know there are a lot of videos in the market, and there are a lot of videos and courses in there. So basically, the issues with all those is like they come up with a lot of classy terms, and I mean it's all very important, but still, you don't require that long unrequired things to start with. So basically I would say, what is actually like people say agent agentic AI and agents and stuff. So what is required, this video we're gonna see on a high level how what is required, and what are the essential things you need to know before you start doing something. Let's say whenever you come across a word called agent, you should know on end to end. Like, you can build on top of word, but at least you should know what is what, right? So yeah, to start with, I'm just starting with an example. So you could see here, like, what I'm doing is like, let's take an example, a person chatting with ChatGPT. Okay, so it's basically a model where a user is telling, show me the prices of Indigo from CB to Chennai on May 4. So we usually use, like, even myself, I use a lot of AI stuff nowadays, and for checking even the basic details, and it's been part of my life, and we all do it, right? So we'll try to understand from here, like, how does are these able to do it. Okay, so if you ask me, if this is given to LLM, like, let's say in ChatGPT we have like a lot of versions, and if one of the model is GPT 5.3, it might be, I mean, the answer might be sorry if you're using only this particular part. The reason is, it is cut off. There is a cutoff date, right? So let's say if the model is trained till 2023, it cannot answer anything beyond that. If you're asking any event to happen in 2024, purely on the training set, it won't be able to answer, and that will tell you, like, it cannot process it, or it can hallucinate at times, but mostly it won't answer. So to solve this, people have come up with a way, like, that's where agentic AI comes in. So what it does is, like, it interacts with the web and gives you the details, like, instead of it along with the training data, it also has an access to interact with the website and give you the details. Okay, that's how it works. So now it won't say sorry, instead it directly tells you the price details of all those whatever you ask. Okay, so what happens here is, once you do that, it goes search on the web, and that's how you get the price details. And on the back end, right, so what happens is, you have a lot of LLM models like GPT 3.4, 5.4, and lot more coming up. And for every models, there is some cutoff date, like based on the training data. Obviously there should be some training date, there should be some cutoff date, because that's how they evaluate a model, and a lot of things happens behind it. But if you want to have something beyond it, that's how you have agentic AI. You can connect with the web by using an API call and get all those details. Okay, so this is on a high level how things work, and what was the issue with the pure LLM models, and that's how this is being rectified, and that's where the agentic AI comes in. Cool. Now let me take you another example. I don't know if you have notified. I'm a big user of Rufus. People pronounce it differently, but yeah, Rufus is an AI version of ordering things in Amazon platform that you see here. So Rufus is, you could see in, it'll be in the taskbar in the bottom, in the top of the Amazon website. So what happens here is, like, it's a, I mean, every product has its own AI, but I really like this Rufus. It's bit standardized and advanced. That's why I took this example for for explaining you guys. So here, if you go, you can try it out parallelly. If you wanna you short, like, go to Amazon, you'll be able to find either on your mobile or a laptop. So what you can do is, here you can, if I prompt, like, I want to buy a shoe with 4.8 plus ratings and the price of 2000 plus, right? So people usually, like, majority of us, since we are smart enough, we do choose the ones that are best and value for money, right? Like, at times we go for expensive stuff, but still, this is the majority of us focus on ratings and price. If you find something very cheaper and still the ratings is very worst, we won't go with that. So this is one of the example I have taken up. So what happens is, it gives you this particular tool. It gives you all the products that are listed, like, shoe from Puma, like a shoe from Nike, and one from Adidas or whatever, right? So it gives you list down all the shoes that you have, like, probably the best top 10 or top 20. And from that, let's say you're interested with the top shoe or the second shoe, you might say that, add the first one to the cart. So what it does is, it will add to the cart. Or if you want to purchase, yeah, you can directly go ahead and prompt, like, get the show done. That's it. So your order is getting placed. Like it might be some, you might even link your bank account with it, whatever. It all happens in the back end. It completely takes care of end to end shopping for you. It's a enabled shopping. Refers is like really good. I would say it's a good value that has been made to Amazon. Like it helps people identify the right product at the right time and whatnot, right? So this is exactly is what happening, and let's try to understand what is happening in the back end. So we understood everything is being done. So basically in the back end there is a model being run. So what it does, whenever you're prompting in such a way that a shoe from 4.8 star rating, so there is a product DB in the back end where you have all the informations of the particular product, might be a metadata or whatever it is, right? So you have some, let's say the shoe, this particular product ID, you might be having the ID of this product, and you might be having the name and other details like price and ratings and comments or whatever, right? So you have that in a table. It might be structured differently, but that's how the product DB looks like in high level. Okay, so you have all those in the product DB. It finds the shoe. I mean, it might be having a category called shoes or something. So it might be pulling all the shoes. That should be the first part that the model does, that the agent does, to be honest. So next is like it filters the one with 4.8 star rating. So it goes and makes a filter, and third step would be to add to cart and checkout and place order. So these are the steps that being followed by the agentic model. So I think you understood, right? So on high level, this is how the backend stuff works. And now getting to the next part. So how does this work on an architecture level? Like how we understood how this works, like on a high level. But now let's jump in on how this works. So you could see the user gives an input. Oops. You could see the user gives an input. So what happens is you have a LLM model being run, as I said. So here, it might, as I said, it has a product DB with it and API to pull the reviews and other stuff, and it has a memory. So basically, you are communicating here, right? So you're telling add the first one. It's basically tells you to. It has a memory. That's how it works. So you're telling add the first to the cart. It's basically based on the memory, and you might be having API checkouts to place out and other stuff. So this is how this is how things are connected. So basically, LLM plus tool plus knowledge plus memory is nothing but your agentic A agent. Okay, so that's how things work. So basically, all this combined is called A agent. Okay, so in words we can say it is a program that takes input. It takes input, uh, thinks and acts to complete a task in autonomous way. So using tools, memory, and knowledge, right? So hope this is very clear and constraint. So now let's try to understand what are the characteristics of model. So what do you say characteristics, like how do you define it by its character? So basically, if you ask me, all the A agents has LLM as a brain. That's the first part. Next, everything is autonomous. These are the important characteristics of LLM, agentic AI. Okay, next. Let's try to understand how this loop works. Like you give a prompt, it thinks, it brings into some action observations, and it loops again. If this goes wrong, it's a feedback mechanism where it loops and rethinks and stuff, right? So that's how things happen, and you have your output there. So next, let's try to understand how how all the models are compared with its agency with respect to its predictability. So let's say we have ChatGPT. So in terms of agents, like if you have got a chance to use ChatGPT, it is basically you have less I mean, you can't expect it to do a lot of autonomous works. You can probably give some less task, and it might be more predictability. The output what you might be getting is a bit more, but I mean it will be more what you expected. But if you ask me if it is more autonomous, no, it is not such a way. So next is Zapier and N8N. It's basically a non-coding platform where you can do things, and it is capable. It's basically a drag and drop place, and where you can build your own agents and stuff. So here, yeah, it's comparatively, it's more agency and less predictability. So next is Cloud Code. So if you have used Cloud Code, it's mostly used for coding stuffs and automating. It might even give you 10,000 lines of code, and such things are being possible with Cloud Code. And yeah, so what happens here is I mean, this is good in doing the code stuff, but again, the expectations that you might have is a bit lower than the other models that you see. Open cloud, it's fully autonomous. If you give a task and if you're waiting, let's say you are thinking that the agent might do it when you wake up on the next day, you may not get things what you are expected. So that's where the predictability goes less for open cloud, but it is more autonomous. Let's say you are giving a simple task or whatever, right? It is more autonomous in doing things. So that's how it works. So that's how you compare between models, and that's the difference between predictability and agency. Okay, cool. Next we're gonna see things about multi-agent system. So multi-agent system is basically, uh, at times in it, when you might be required to have multiple agents. Only single agent is not capable of doing things. That's where you might be allocating subtasks to other agents. Like, you might be having a dedicated agent for building a task and sort of things, right? So multi agents basically collaborate, each handling a subtask. So that's how it does work. And it is also used when the problems is too complex, as I said, to solve, one by one agent. So basically, agent might be assigned with one particular task. The subworks are taken by each and every agent. So example, let's take a code agent. Let's say you are using a Claude and you're using an agent to optimize your code or something like that, which people use a lot. And here, like, what happens, the very first step is like to plan on how to do it, what sort of language is it, and how do you optimize it, and things like that. Next is the code writing agent, which does the coding itself, and might be optimizing it accordingly by the whatever is asked in the prompt, or might be adding couple of lines or whatever it taken care by the second agent. And third agent is code review agent. It reviews whatever the code is being written by the agent 2. And that's how it reviews, and it has its own frameworks to identify if there is any bugs and redo it if it is not doing well. And then we have the final step to test, like, give some prompts and see how the latency is and other things, right? Cool. So this is how things are being done. Next is like multi-agent model. So multi-model agent. So what is multi-model agent? Multi-model agent is basically, let's say other models we have only text, right? But nowadays, if you see ChatGPT and other even Claude, whatever, right? So you have like image, audio, and video processing as well. So that's why we call it as multi-model agent. Example, Gemini image options, and you can give some images and make it, optimized, or make the resolutions even more higher, things like that, right? So that's basically is what multi-model agent is. And there are models which only handles text. If you ask me, Claude is more capable of doing text, and I don't know if that is capable of doing images and stuff. So that's what multi-modal agent is all about. And next is health insurance company example. Like, let's say a agent might be need to extract from the prescription ID card and stuff like that they have to do some image processing and also the text processing, and some document classification. So all these has to be run behind multi-modal agent. So it also needs to generate images and stuff, not only text, it has to generate images. So that's why we call it as multi-modal agent. Next is how do we create a agent. So before going there, I think let's complete this. This is much more easier. So creating a agent is basically quite simple. So let's say we have two ways of doing creating a agent. The one thing is like coding framework, which is widely used. You have LangGraph, LangChain. It's basically a Python library. You can just like import it and use it, and you should know coding to do this. It's a coding platform. And next is like True AI and Google ADK's couple of famous frameworks that you have for coding with respect to the building of AI agent. And next is no code tool. It's basically you have like N8N, Zapier. These are a couple of popular tools where you need not code. Like people without coding knowledge can go ahead and create their own agents. So that's typically how this is being used. And so what is the advantage of this? Like, let's say people is not familiar with Python or any other programming languages, they can go ahead and use these tools. And it's also user friendly. It's very easier to create. It has its own advantage again. And next is A application. So whenever people say A application, right? So what how do you define A application? These are classified into two types. One is agentic, another is workflow. So agentic is what we saw as of now, where you have agents to do things, and you have multi agents to do multiple subtasks, and you have multi model where generates images, and and classifies documents and stuff, right? So we are also having workflow, and I would say this is what is, what majority of the companies uses, and where the AI agents is part of the project. It's not the entire thing. So basically, LLM is one of the component of the project used for a specific task. It's not like the entire thing. So for example, let's take, I have seen this. I don't know if you got a chance to see some websites where will have a button to summarize things. Okay, so here you could see a news article where there's a button called summarize it. So basically, you need not read everything. You just give this button, you get the summarized, two-liner or three-liner of it. Basically what it does is it reads the article, so it is a predefined one. It is properly instructed in the website. So what it does is that the article text is being given to the pre-processing, where you do some cleaning stuff and other things, and then it is given to the LLM, and you have the post processing stuff, and you get the summary. So there is nothing else. There is no other complex things that are getting involved. So where this particular thing is part of the workflow. The main work is to display whatever you have, whatever the news you have, but this is being part of it is what I'm just trying to tell. So then you show it in the article. That's how the summarizing work. And there is no API call. You don't call uh, other agents, or there is no other call for any other applications and stuff, right? So there is no API call involved, and there is no control flow. uh, there is no, you don't control, like, at times if you're working with agents, like, you might be directly involved. I mean, the agents will decide on how to control, on how the flow has to be, but here we're not decided. It is already predefined, and things work very smoothly. So these are the things. Whenever you have AI application, it might be fully agentic, it might be partially. When I say partially, it might be a part of your project. That's why it's called as workflow. Cool. Getting to the last topic, we have Gordonals. So what is Gordonals? It's basically, you do all these things. Okay, it's all fine, but do you think it's all good? But you have a lot of challenges in it, right? So what are the challenges? You have chances of hallucination. The model might give you wrong answer. Even in critical situations, you might get those issues. That's why, there are cases where companies are paid a lot of fine for it, and that's how things work. Okay, so hallucination is something there that's been avoided if you're using Gordons. I'll tell you how exactly this is done. And stop leaking confidential information. Let's say you have provided some bank details and some personal details about you. It has to be it shouldn't be leaked. And secondly, if the model has some information about the company, some confidential documents or information, it shouldn't be leaked to unauthorized persons, and these are something that should be avoided. And also to handle out of scope questions. Like, let's say there are examples where a food ordering chatbot was doing a programming question which is irrelevant, and those things should be handled, right? Another is like, jailbreak. They call it as jailbreak. Is basically the model breaking its own, the purpose of what it does. That's why we call it as jailbreak in the AI world. So basically, we also should handle offensive information. Let's say if you're asking some, let's say you wanna do a robbery, or you wanna break a jail, how do you do it? These are all offensive things, and that's how we should control those things in the model. That's how that's called as guardrails. So it's basically, that's where it is being introduced. For example, we use middleware. It's a part of, for example, in the finance agent. So we the customer data, we use like credit card details and email, where you mask it and redact it. So basically, you could see the credit card details are being hidden, and the email is basically uh, it's hidden in such a way that the entire information is not leaked, and you have only the first and the last characteristics or something. So someone who's pulling the info will not, they cannot do anything with it. It'll be completely secured. Okay, that's the idea of this. And next is model evaluation. So still, like, I mean, this is one of the best example. I would say even we are losing a lot of data nowadays. Like, you might be getting a lot of spam mails, a lot of calls. Basically, some of the data is being, it's not that you're using bots. It might be because of other things as well. Like, they might be getting your details from some other sources as well. So we doesn't know. But this is also a threat for that. We shouldn't avoid. I mean, we should ensure that the model should ensure that this is not being done. And apart from that, even the owner who's owning this particular platform shouldn't be getting all those details. That's how that's how you evaluate a model before doing those things. Next is, how do you evaluate a model? So yeah, you done with everything, you secured it and you did all those things. Now if someone asks you how good is the model, how would you answer them? So that's where the evaluation comes in. Okay, so what is evaluation? It's basically, there are three types of evaluation. So we have like functional evaluation, cost, and safety. What is functional? Functional is the essential thing what the model has to do. How does the model answer the questions? And second is like, is there any hallucination? How faithful is the model is? So for example, we how do we test it? We give the input, and we pass the input, and we have also passed the expected output, and see if that is matching. It's not an exact string match, obviously it won't be an exact string match. You know how the model works on the back end. So it won't be exact string match, but still we have certain things called cosine similarity functions, where you use those. So basically it compares the context, it compares the context and gives you a score based on the input, so based on the output and the expected output. So that's how things work. And next is like, that's how you check the functional evaluation. And you also have like Langsmith is being used for the similarity match and latency checking and token usage. Now let's come to the cost evaluation. That's where the token and latency comes in. So its cost is also important. You are using it for a production level thing, where people are going to use on a day-to-day basis. And if it consumes a lot of tokens, which means you are paying for it, the brand pays for it, the company pays for it. So which means it should be minimum process. It shouldn't be taking much tokens, which might backfire the company, because it's something that we are advancing the tool. It doesn't mean that it should cost much higher. Okay, so that's again, this is very important. Token usage, we have to cross. Most likely you won't get it. It should be, if you're precise about your things, it won't happen. But let's say if the customer is very generic about things, it might need to process a lot, and it might cause in a lot of tokens. And is the model is able to capable of handling it, is what this particular thing tells you. And latency, yeah, again, like let's say you're a user, you're chatting to the chatbot, and if it takes a lot of time, how it's not a good thing, right? Like you have to get it very promptly. That's exactly where it also involves a cost, like because you're waiting for a lot of time, and it might charge a lot of you waiting for a lot. There might be some lot of token consumption. So that's what the cost evolution comes in. And we can also compare output from different models. Let's say you have GPT 3.5 and 3.2. You can see how good is the models being done, because everything is being trained on different data sets, and the way it is trained might be different, and it might be more adaptable to your own data and stuffs. So it depends. So you can use whatever. You can even use other models from different companies and see how it works and stuff, right? So that's why you can compare this in the Langsmith itself. And next is like safety evaluation. This is really important. Like, how is the confidentiality leak is being done, and the jailbreak thing, how good the model is being, is being restricted with its own constraints and stuff. And is there any confidentiality leaks and stuff? It's very important. So for this, I even tried an example. I tried myself chatting to a bot here with Claude. I was trying to see if that is able to break it, and even with Gemini, I was trying to do the same. It was performing very well. The answer which I got was like, it is restricted not to say those things, and I was tweaking a little bit to get something from it, but no way, it was not answering, and which means it was being well handled by GPT and Claude. So hope this session gives you a high level idea on how things works, and really helpful for you to understand things. This is on a high level how things works. So in the future sessions, we'll be breaking down things like understanding each and every part. And for now, I would guarantee that you understood, whatever is being there in the AI field. And yeah, thanks a lot for watching the video till then. Thanks a lot. Have a great day.